So today we're going to talk about trig substitution, which is a way to evaluate integrals with radicals in them or without radicals. But that only is for tangent, but we'll get to there. So we have this handy dandy chart that my own math teacher provided us, and I find it really useful. So basically we have one column that says see this, use this, in the friend. So if you see a squared, that's a is just some number, a squared minus x squared, the square root of that, you're going to use sine. And then your friend is cosine. We'll get to what the friend means. If you find square root of x squared minus a squared, you're going to use secant. And the friend is tangent. If you have x squared plus a squared, or the square root of x squared plus a squared, you're going to use tangent, and your friend is going to be secant. So this will be a lot more useful to you if you actually know how to do trig substitution. So what we're going to do here is we're going to evaluate this. 1 over the square root of 9 minus x squared dx. So let's go down this column. So it looks like, since a is a number, our a is 3, right? So the first thing we do is we set it up as x equals 3 sine theta, right? We're going to use this. Now the next step is to find the derivative of that. So dx equals 3 cosine theta, right? The next thing we're going to do is that we're going to solve for sine of theta, and we're going to set up a triangle so that we can solve for the remaining side. So let's divide by 3 to get x divided by 3 equals sine of theta, going from this equation here. So let's set up our triangle, right? Let's say this is the angle that we're going to base all of our sides off of. So using the previously known SOHCAHTOA rule that I learned in geometry, sine is opposite over hypotenuse. So this side is going to be x and this side is going to be 3, which leaves this side to be square root of 9 minus x squared. Right? Pythagorean theorem? Okay. Now this is where we use our friend. So since we use this row here, our friend is going to be cosine. So what we're going to do is we're going to find cosine of theta. Cosine of theta is adjacent over hypotenuse. Adjacent is 9, the square root of 9 minus x squared, and then divided by the hypotenuse. So you'll notice here that you're sort of starting to see where you can plug things in. But see here, we don't have the square root of 9 minus x squared divided by 3. We only have the square root of 9 minus x squared. So what we're going to do is we're going to multiply both sides by 3 to get 3 cosine theta equals the square root of 9 minus x squared. Now you're ready to substitute stuff in. And it's called trig substitution because you have numbers and x's here, but you're going to end up with cosines, sines, tangents, secants, etc. Right? Okay, so let's rewrite this as 1 over, so this is the equivalent of 3 cosine theta, excuse me. And then we can't forget this dx right here. So times our dx is 3 cosine theta too. Right? Okay, so now you'll notice that a bunch of, let me not forget d theta. Now we're going to notice that these two things are just going to cancel out, leaving us with d theta. Now the integral of d theta is theta. But we can't just leave it as theta. We've got to plug it into, we've got to make it into terms of x, right? So what we're going to do is we're going to use arc sine, excuse me. So if we solve backwards from here, we're going to get x divided by 3 equals sine of theta. And what we're going to do next is we're going to take arc sine of both sides, okay? Arc sine of x divided by 3 equals theta. This is another sort of idea that you should learn from geometry, but if you don't know, you can just take arc sine. Arc sine is like the inverse of sine, so it basically works how an inverse works. So what our final answer is going to be is arc sine x divided by 3 plus c. Right? And that's how you can use trig substitution to evaluate integrals that you don't really know what to do with, because you can't use u-substitution. There's no x to be seen here. You could just use trig substitution, which in my opinion is a very easy way to evaluate integrals. So this is sine. I'm probably going to have 2 more videos with secant theta and tangent theta. And I'm also going to include a video about how you do this with completing the square, which is kind of a bit harder, but nothing that anyone shouldn't be able to handle.